Hi everyone, in this video we will take applications on the derivative of the trigonometric functions, and the first application in part A is the ladder problem. So the question is, a 10 feet ladder leans against a wall at an angle theta with the horizontal. The top of the ladder is x feet above the ground. So this is x. If the bottom of the ladder is pushed toward the wall, so this is the direction of the ladder, find the rate at which x changes with respect to theta. X with respect to theta when theta equals to 60 degrees. So firstly, here the angle in degrees, so you have to convert it to radians, and as you know, each pi equals 180 degrees. So if you divide by 3, you will get 60 degrees equals to pi over 3. And as you know, the rate of change means the first derivative. But here you have to find the rate of change which x changes with respect to theta. So you have to find dx by d theta when theta equals to 60 degrees. In radians we have pi over 3. So this is what you want to find. Here we have a right triangle, and here is theta. So x is the opposite side in our problem, and the ladder is the hypotenuse. So what trigonometric function relates the opposite with the hypotenuse? It is sine of theta. So we can write sine theta equals opposite over the hypo. So sine of theta equals the opposite is x over the hypotenuse, which is 10. Here you have to do cross multiply. So x times 1 is x equals 10 multiplied by sine of theta. Now we have a function x with respect to theta, and you have to find the derivative of the rate, or the rate of change of x with respect to theta. So dx by d theta, dx by d theta equals 10 multiplied by cosine of theta, since the derivative of sine is cosine. Now you have to find it when theta equals pi over 3. So here we have 10 multiplied by cosine 60 degrees, or pi over 3, and cosine 60 is 1 over 2. So we have 10 multiplied by 1 over 2, and the answer will be 5. So this makes sense because the answer is positive. This is true because this is the direction of the ladder. So x increases and theta increases in this direction. And this is the end of part A. In part B, we have an airplane application and the derivative of trigonometric function. So the question part B is, an airplane is flying on a horizontal path at a height of 3,800 feet as shown in the accompanying figure. At what rate is the distance s between the airplane and the fixed point P changing with respect to theta when theta is 30 degrees. Now you know that pi is equals to 180 degrees, and if you divide both sides by 6 you will get 30 degrees. So 30 degrees is pi over 6. This is the first idea. Secondly, you have to find which is the suitable trigonometric function that relates this number with s. Now this is the opposite side because we are talking about the right triangle, and this is the adjacent, sorry, this is the hypotenuse. So what is the suitable trigonometric function relates opposite with hypotenuse? It is sine theta. So sine theta equals to opposite over hypotenuse. So sine theta equals, the opposite here is 3,800 divided by the hypotenuse is s. Now we can do cross multiply, and you'll get s sine theta equals 3800. Then you have to divide both sides by sine theta, divide by sine theta, divide by sine theta. So cancel sine with sine, and you get s equals 3,800 divided by sine. Now move sine theta up, you will get cosecant theta. So we have 3800 multiplied by cosecant of theta. Now you have to find the rate of change of s with respect to theta. So what you have to find is ds by d theta when theta equals 30 degrees or pi over 6. So this is what we want to find. So the derivative of cosecant is ds by d theta equals 3800, and the cosecant is negative cosecant theta cotan theta, and we can write it as negative 3800 divided by, now move this down and move cotan theta down, you will get sine theta times tan of theta. Now you have to replace or plug in theta by pi over 6. So theta equals pi over 6 or equals to 30 degrees, which is equal minus 3800 divided by sine of 30, and it is 0.5 multiplied by tan of 30, and tan of 30 is 1 over square root of 3, and using calculator the answer will be minus 13163.5864. So this is the final answer for this question, and that's it. In part C we have a searchlight problem, and the question is, a searchlight is trained on the side of a tall building. So this is the building. As light rotates, the spot it illuminates moves up and down the side of the building. That is the distance d between the ground level, this is the ground, and the illuminated spot so this is the search light and this is the illuminated spot. On the side of the building is a function of the angle theta formed by the light beam and the horizontal. See the accompanying figure. If the searchlight is located 50 meters from the building, find the rate of change or the rate at which d is changing with respect to theta. So you have to find the rate, and as you know, rate of change means the first derivative. So you have to find the rate at which d is changing with respect to theta. So you have to find d by d theta when theta equals to 45, and 45 degrees equals to pi over 4 in radians. So you have to find this derivative. First you have to make formula between d and theta. As you see, this is a right triangle and d is the opposite with respect to angle theta. So this is the opposite side, and 50 here, which is the distance between the building and the searchlight, is the adjacent. So the trigonometric function that relates the opposite with adjacent is cosine theta. Cosine theta equal opposite, sorry, tan theta equal opposite over adjacent. So tan of theta equal the opposite, which is d, divided by the adjacent, which is 50 in our equation. Now you have to do cross multiply, and you will get d times 1. D equals 50 times tan of theta. Now what is the derivative of tan? The derivative of tan is secant squared. So you have to differentiate both sides, and you will get dd by d theta equals 50 multiplied by secant squared of theta. Now this we can write it as 50 over cosine squared of theta. Now you have to replace theta by 45 degrees or pi over 4. It's up to you. So you will get 50 over cosine squared of pi over 4, and cosine pi over 4 is equals to 1 over square root of 2. So you will have 50 divided by 1 over square root of 2 squared, and this gives us 50 divided by 1 over 2, which is 50 times 2, and the answer is 100. The answer is positive, and this makes sense because here when the beam is go up, d will increase and the angle also will increase, and when the beam decreases, then d will decrease with theta. So the rate of change of the distance d with respect to theta will be positive here. And this is the end of this example, and that's it. Thank you.